Welcome to clickmyproject.com. Let us see the title of our project. Our project title is Brain Dynamics in Predicting Driving Fatigue using a recurrent self-evolving fuzzy neural network. Let us see the abstract of our project. EEG is a recording of an electrical activities of the brain from the brain waves produced by an electrical current passing through the nerves during the brain activities. The classification of an EEG signal can be helpful in monitoring the patient and identification of the different brain activities. The EEG signals were classified based on the statistical features obtaining from the different segmentation of an EEG signals. The EEG signals were segmented with the help of a HST transform. The segmentation signals were then classifying the neural network classifies, then the neural network pattern recognition tool that identification the types of signals by analyzing the patients of the features. The elliptical fatigue occurs in the intermediately and unpredictably. Mindless detecting in ECG is highly required. In our method, the HST based time frequency representation TF4 has been considered as a time frequency image, a TFI. The segmentation of a TFI have been affected based on the frequency bands of the rhythmic of EEG signals. The histogram of the grayscale subimages have been denoted. The drift of avoided in the trade-off between the time and the regulated fairness. The wavelet theoretical is limited by the fundamentals of uncertainty principle. The stages of a WVT is the serves of crossing the terms indicate by the existence of negative power for some frequency. The identification of a fatigue based on the feature extraction is more efficient compared to the other feature extraction method employed for the analysis of the signals. Let us see the objective of our project. The main objective of the process is to find the given EEG signal is a fatigue signal or a non-fatigue signal, and acquiring an ECG signal from a mentioned dataset, to segmenting the signal into individual pieces and extracting the features, the classifying and detecting the drowsy persons by the neural network classifier, to analyzing the performance in the terms of overall accuracy. Let us see the flow of our project. First one is a signal acquisition. Here I get the input signal from the dataset. Then the input signal is given to the ECG drift elimination. Here the eliminating the drift values. Then pre-processing is done. The pre-processing step containing a high pass filter and the low pass filter processing. Then the low pass filter value goes to the HST transform. The HST transforms then segmenting the signals using the wave function. The segmenting the particular waves then given to the feature extraction. Then optimizing the optimization using a GA algorithm. Then classification is done. The classification using a fuzzy neural network. Then performance evaluation is calculated. The performance evaluation contains the accuracy, sensitivity, specificity and the corrected and the error rate of the classifier. Then the confusion matrix is displayed. Let us see the output of our project. Go to your current folder, then select the main.m file, then run the project. Now I selected a 4.mat file. Now run the project. The input signal is 4.mat file. Then the DCD drift elimination is done here. Here eliminating the unwanted noises and pixels. Then the digital high pass filter is applied here. Then the digital low pass filter is applied. The digital low pass filter value is goes to the HHT transformation. The Hilbert transform is done here. Then the segmenting the Hilbert transform signal. Here segmented values are a gamma, beta, alpha, theta, delta value, delta signals. Then the segmented values goes to the feature extraction method. Here I extracting the feature values. Then the GA is used to optimizing the feature value. Then the neural network classifier is done here. Here I selected the input is 36 layer and the hidden layer is 20 and the output layer is 1. Now I run the confusion matrix. The classification is a non-static signal. This is our performance evaluation. Thank you for listening. Our demo is completed.